Hey there, 6th grade. The topic of this next video is powers of 10 and scientific notation. And so we're going to start out with a fact here, and that fact is that the distance from Venus to the Sun is over 100 million kilometers. So that's a little ways away. We're going to talk about how you can write this large number 100 million a little bit shorter of a way using a base of 10 and an exponent. So we learned in the last lesson that repeated multiplication can be shortened by using exponents and bases. So this number 100 million here would be the repeated multiplication problem 10 times 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 10. And so from the last video we learned that as a power we could write this with a base of 10 and an exponent of 8. And that would be 10 to the 8th power. In this table below, we're going to show a few different examples of different powers of 10. So here I have 10 to the first power. 10 to the first power means you just have one individual 10, and of course its value is 10. 10 to the second power means you have 10 multiplied by itself twice, so 10 times 10, and that is 100. 10 to the third power is 10 times 10 times 10, which is 1,000. And then 10 to the fourth power means 10 times itself 4 times, and that gives you 10,000. Okay, so now let's look at this multiplication problem in example 1. We're asked to multiply 21 times 10 to the fourth power. Well, based on this table up here, we know that 10 to the fourth power is equivalent to 10,000. So I can rewrite 10 to the fourth power as 10,000. And also notice that the exponent on that base of 10 tells you how many zeros are going to be in this value. Okay, this is 10,000, and 10,000 has 4 zeros. That matches the exponent of 4. So now I just need to take 21 times 10,000. Okay, 21 times 10,000. Well, 21 times 1 would be 21. But since we're multiplying by 10,000, we just need to add on those 4 zeros to this number. So that would be 210,000 when we tack on those 4 zeros. You can also find the product of a number and a power of 10 simply by moving the decimal point of the number. For powers of 10 with positive exponents, which is what we're going to look at today, you move the decimal point to the right. There are such things as negative exponents as well, but we're not going to get to that today. So for today, we'll be dealing only with positive exponents, and when we multiply by powers with positive exponents that have a base of 10, we move the decimal point to the right. So let's look at how this works. For number 2, I have 137 times 10 to the third power. So I want you to think of 137 as a decimal. Okay, how would you write 137 as a decimal? Well, it would be 137.0. And remember, for whole numbers, everything to the right of the decimal point is just zeros. So really, I could write this as 137.0000, and I could keep going and going as far as I wanted to with zeros. Okay. And if I'm multiplying this number times 10 to the third power, well, what that means is I'm taking my decimal point, which is right here, and I'm moving it 3 places to the right. So I'm moving it once, twice, and 3 places, so it ends up here to the right of this third zero. I moved it 3 places to the right because the exponent on this power of 10 was 3. So what new number do I get now? Well, now I have 3 zeros that come before the decimal point, and so this is 137,000. I'm going to do the same thing for number 3. Number 3, I have 46.2 times 10 to the fifth power. 46.2 is already a decimal, so I just need to take the decimal point on 46.2, and I'm going to move it to the right. What comes after the 2 in the 10th spot on this decimal? Well, that's just going to be more zeros. So now I'm going to move my decimal point here 5 places to the right because my exponent is a 5. So that's going to be 1, 2, 3, 4, 5, and now my decimal point will go here to the right of this fourth 0. So my new number is 462, and then I have 4 zeros, 0, 0, 0, 0, and this is actually the number 4,620,000. Okay, going to the back side, now we're going to talk about what is called scientific notation. So my answers to problems 2 and 3, this 137,000 and this 4,620,000, are examples of what is called standard form. Okay, we write most numbers in standard form. Okay, and that's when we use our commas and our large numbers. Okay, 17,900,000 is another example of standard form. However, we have another form that we can write large numbers in, and that form is called scientific notation. Okay, scientific notation is a shorthand way to write very large numbers, and you'll often see scientific notation in science class. So in scientific notation, let's take this example, 17,900,000. We have a number that is greater than 1 but less than 10, and we multiply it times a power of 10. And that's what I have written down here in this red and blue font. Okay, a number, and it can be a decimal, between 1 and 10 times a power of 10. And that's usually a shorter way to write large numbers. So this, for example, is how you write 17,900,000. You write it as 1.79 times 10 to the 7th power. So in examples 4 through 5 here, we're going to practice writing each of these numbers in scientific notation. Okay, so for number 4, I have the number 9,580,000. So what I'm going to do is I'm going to imagine where the decimal point is on this number. And because it's a whole number, the decimal point is going to be to the right of this last 0. So there's my decimal point. In order to get this number in scientific notation, I need to take that decimal point and I need to move it left until I get a number that's between 1 and 10. So let's count how many places we need to go. We need to go 1, 2, 3, 4, 5, 6. When I move this decimal point 6 places to the left, I get the new number 9.58. Okay, 9.58 is greater than 1 but less than 10, so that's going to be the first number in my scientific notation. What comes after that is a time symbol, and then we're going to write our power of 10. 9.58 times 10 to the 6th power is the scientific notation form of 9,580,000. Now, why did I choose a 6 for my exponent? Well, look back at the number of places you moved the decimal point. We moved our original decimal point here 1, 2, 3, 4, 5, 6 places in order to make this 9.58. So that's why I'm choosing a 6 for my exponent. So that exponent is the number of places you moved the decimal. Let's do the same thing now for 813 million. Okay, so we're going to imagine where the decimal point is on 813 million, and the decimal point would be to the right of this last 0. So I need to take this decimal point and I need to move it to the left until I get a number between 1 and 10. So there's 1, 2, 3, 4, 5, 6, 7, 8 places I've gone. So now I'm at 8.13. And to write this in scientific notation, it needs to be 8.13 times 10 to, how many places did we move our decimal point? We moved it 8 places, so this is going to be 10 to the 8th power. Okay, in this last example, we're going to do the opposite of what we did in those previous examples. So I'm going to take the scientific notation, 3.7 times 10 to the 9th, and I'm going to write this number in standard form. Well, this is the exact same thing as what we did in examples 2 and 3. We're going to start out with our decimal, 3.7, and we're going to think of this as having all of these zeros after the 7. we want to get a large number here. Okay, so we're going to move this decimal point to the right, and we're going to move it to the right 9 places because our exponent here is 9. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's count how many zeros that is after the 7. That's 1, 2, 3, 4, 5, 6, 7, 8 zeros we'll need after our 7. And so this would be quite a large number. This is actually 3,700,000,000. Okay, so if you had any questions over this video, anything that didn't make sense, I want you to be sure you write those down on the notes so that you can ask your teacher the next time we see you in class. And until that time, have a nice day. You're all wonderful people. Take care.